Hello, and welcome to Team Alpha's Skeletal Increment demo of the Clueless board game for the Foundations of Software Engineering course at Johns Hopkins University for the Spring 2025 semester. In this presentation, my team members and I will give an introduction of the team members, the product that we are creating, the subsystems involved in the product, the relation of subsystems, the risk assessment, schedule updates, and a demonstration of our progress so far. Here in this slide, I'd like to provide a brief overview of the group members, their different roles, and an overview of the product being designed this semester. In regards to the group introduction, Ria is the program manager. As the program manager, Ria is responsible for overseeing the project timeline, ensuring collaboration among team members, and maintaining project efficiency. The program manager monitors project milestones and ensures that tasks are completed on time. Josh is the lead architect. As the lead architect, Josh is responsible for designing the general system architecture. The lead architect coordinates with the other developers to ensure that the team understands the general architecture and follows its structure. Hyunjin is the lead tester. As the lead tester, Hyunjin is responsible for ensuring the game functions correctly by thoroughly testing inputs, outputs, and interactions between subsystems. The tester will verify that each system processes given data correctly and produces the expected results. The tester will also identify and test edge cases, uncommon or extreme scenarios, in the program. Paul is the lead programmer. As the lead programmer, Paul is responsible for overseeing the development of the game's core systems, ensuring performance, scalability, and maintainability. The lead programmer guides the other developers, monitors tasks, and ensures coding best practices. Leah is the lead software quality manager. As the lead software quality manager, Leah is responsible for ensuring that the game meets the project standards by reviewing testing strategies, documentation, and code implementation. In regards to the actual product, the product this team is creating is a simplified version of the popular board game Clue. While this version of the game has the same 9 rooms, 6 weapons, and 6 characters as the original game, the main difference is in navigating the game board. The Clueless game is divided into 3 major subsystems. The first is game logic, how the game operates and performs its required functionality. The second is network, how information is transferred between the game server and the players of the game. The third is database, how the data regarding each individual player as well as the game itself is stored. Further information regarding these subsystems as well as how they interact with one another are described in future slides.
Hello, my name is Joshua Delosa, and I will be talking about the relationships between the 3 major subsystems. Our 3 major identified subsystems are the game logic, network, and database. All 3 subsystems rely heavily on each other, which is why they are all necessary to run the game properly. If one of the subsystems is missing from the program, then the game cannot function properly. The game logic is a subsystem that handles the main functionality of the game. It works with the network subsystem to provide the user with the proper interfaces and logic to play the game. The game logic is the main structure of the game that allows the player to actually play, but the game cannot function without a way to store data or communicate between the server and client. The network subsystem is comprised of the client and server. It takes the inputs from the user and verifies that the inputs are correct based on the game logic and current game state. It then updates the game state by updating the database. The network is the main messaging system that allows for proper verification of user inputs and updates the database. The database is in charge of the current game state. It stores all of the user and game information. The database will send the network the current game state based on the user's inputs and then update the game state as the game continues. Without the database, the network cannot provide the game state or verify that the user is making valid inputs for the game. These relationships between the 3 major subsystems show why the game cannot function properly unless all 3 are properly implemented.
Hello, I am Paul Bogner, and I'll discuss our subsystem communication setup. First, we have our Redis server. Redis is used as our message broker to handle real-time communications for the WebSocket connections. It helps synchronize the game state across all players' clients in real time. Second, we have Daphne, our ASGI server for the HTTP and WebSocket protocols. Daphne is an asynchronous server that allows for the real-time nature of the game, especially during players' movements or updates. Last, we have our Python Django server. Django serves as the main application server, handling the HTTP requests for players' logins, game state retrieval, and other general HTTP routes like the game's main page and login or setup functionalities. Now that we know what applications we are using for our subsystems, where can we find them? Our game logic subsystem can be found within Django, responsible for core gameplay mechanics. Our network subsystem can be found within all three applications, with the client being handled by Django through HTML and JavaScript for a user-friendly interface, while the server is handled by all three applications, creating real-time communications, handling incoming requests, processing game logic, and communicates with both the client and the database. And our database subsystem is contained within Django, managing both the game data and its persistence through models and migration. So how do our subsystems communicate with each other? We have game logic and network communication to send game updates to clients and receive player input. There is network to database communication for retrieving and storing game data based on player actions and the current game state. And last, there is database to game logic communication to determine truth for initializing the game and any actions taken. Here we have an example of player's movement. Step 1, they have selected the space they want to move to on their client. Step 2, the location selected must be verified by the game logic as a valid move. Step 3, if the move is valid, the game logic sends the player's new location to the database to be updated. Step 4, the database confirms that the game state has been updated. The network then broadcasts the new game state to all connected clients.
Hello, my name is Leah Dillard, and today I'll be providing an update on our risk assessment and the steps we're taking to mitigate potential challenges. Effective risk management is essential to keeping our project on track, ensuring that we meet our deadlines while maintaining quality. Our approach involves identifying key risks, assessing their impact, and implementing strategies to minimize disruption. Our primary risk here revolves around the complexity of our Django-based game architecture. The impact level is high, with a medium probability of occurring. If development becomes too challenging, it could cause delays, requiring extra debugging and slow down progress. To mitigate this, we are continuously evaluating our approach and simplifying where we can. Another major risk here is the need to switch from Django to Godot. While the probability of this happening is low, the impact is still high, as it will require a major system rework and could disrupt our project timeline. We are monitoring the feasibility of Django and will make a decision very early on to minimize disruption to our production timeline. Communication delays or misunderstandings present a low impact but medium probability risk. Slow responses or unclear expectations can lead to delays in collaboration and an increased risk of errors. To mitigate this, we encourage regular check-ins, clear documentation, and proactive discussions to ensure alignment across the team. Varying programming skill levels also pose a medium impact and medium probability risk, as this exists among many software development teams, even in the professional space. Uneven experience could lead to workload imbalances and slower development progress. We are addressing this through structured code reviews, pair programming, and knowledge sharing sessions, if necessary, to support all of our team members. Finally, misinterpretation of deliverables could carry a medium impact but a low probability of occurring. Misunderstanding requirements may result in unnecessary rework or missing key elements in our final submission. To prevent this, we are carefully reviewing the project rubric, clarifying expectations, sticking to our schedule, and maintaining thorough documentation. By proactively identifying these risks and implementing mitigation strategies, we aim to maintain stability in development and ensure a successful project outcome. Now, to effectively manage risks, we assess impact and prioritize tasks by identifying potential challenges and categorize them as low or high priority. Our vision document serves as a guide to ensure we stay aligned with project goals, and if major issues arise, we adjust our priorities accordingly. Essential gameplay features always take precedence over optional enhancements. To manage our workload efficiently, we rearrange features when necessary. Less critical features may be pushed to later stages, allowing us to focus on core gameplay mechanics first. Optional features may be moved to our dream increment, meaning they could be skipped if time constraints require it. This ensures that we meet core project requirements without unnecessary delays. Beyond technical risks, we are recognizing the additional challenges as mentioned before, including communication issues, varying programming skill levels, and potential misunderstanding of deliverables. Clear communication will be crucial here. This will be emphasized through regular check-ins, documentation, and proactive discussions to ensure alignment. To support continuous development and risk mitigation, we utilize GitHub for version control and collaboration. Every feature is developed in separate branches, preventing unfinished code from disrupting the main development branch. Pull requests and code reviews can help catch potential issues early, while automated testing might ensure that new changes don't break existing functionality. We are looking into implementing this. This process will keep our codebase reliable and our collaboration very smooth. By staying focused on our core deliverables, we ensure that every feature aligns with the project goals and that we meet deadlines efficiently. With GitHub as our central repository, we will maintain transparency, track changes efficiently and effectively, and ensure that work continues even if individual team members face setbacks. By following all of these strategies, we will manage risks effectively, maintain quality, and deliver a successful project. And if anyone on the team identifies new risks, they will be brought into our next meeting, and we will address them very proactively. Thank you. Now, I'll be providing a brief update on our project schedule and how we are adhering to the course deadlines to ensure timely deliverables. So far, we have successfully completed our vision document, requirements, and skeletal system demo on schedule. These early milestones have provided us with a clear foundation for development, outlining our project goals, necessary features, and initial implementations. The next major milestones include design documentation, minimal system demo, and target system demo. These upcoming deadlines will help us transition from the skeletal framework to a more refined and functional version of our game. At this stage, there are no major updates or delays to report. We are staying aligned with the course schedule to ensure each deliverable is met without last-minute bottlenecks. To maintain this momentum, we aim to have programming completed about halfway between increments. This approach will allow us to provide full transparency on progress, effectively integrate our code, and leave enough time for debugging and refinement before each milestone. By following this structure, we ensure that our development is well-paced and we avoid rushing critical components. As we move forward, our focus remains on maintaining clear communication, integrating work efficiently, and keeping development aligned with our planned timeline.
Hello and welcome, stakeholders. I'm Hyunjin Kim, and today I'll be representing the demonstration of Team Alpha's Skeletal phase demo. We aim to deliver as much as possible ahead of schedule, considering the limited availability in April and the challenges of scheduling meetings with our team spread across 4 different time zones around the world. Now, let's get started. I've already started the Redis and Django servers. Now, I'll demonstrate the user sign-up process. Let's say player 1 signs up in our system. Once the sign-up is successful, the client receives the success message. When a user tries to sign up with the same username but a different password, the client receives an error message. We've ensured both sign-up and login pages are center-aligned. After logging in, the player enters the game with the specified game ID. In this demo, Game 1. The player's username and character are displayed centered at the top. I've already signed up player 2 through 6, each assigned a unique, randomly selected character. Whenever a player joins the game, their entry is broadcast to others, and their initial location is set according to the game rules after their first move for now. Player 7 cannot join the game since it's already full. The client receives an error message. The database is designed so that the game table stores a list of all players who have ever joined the game based on game ID. This design allows the game to save its status if paused in the middle of play by consensus and resume later. This feature is marked as Dream Feature in Project Plan. Players can rejoin the game. The player table includes an isActive attribute to track whether a player is currently in the game. This allows players to leave and rejoin while the game is running. Regardless of whether some players leave, the game will continue. To implement this feature, when the player logs out, isActive is set to false in the code, then will not be able to move to a new location. We implemented UI auto-scaling so the interface adjusts automatically to different screen sizes, ensuring a consistent and accessible experience across devices. Players can move across the game board by clicking on their desired location. Movement follows the game rules, allowing moves from hallways to rooms, rooms to hallways, and secret passages to diagonally opposite rooms. Before moving to a new location, the system checks whether the move is valid. If the location is not valid, the player receives a notification, invalid move. New location is not adjacent to previous location. Here are some examples of player movement. If the player clicks on their current location, they receive a notification, "You are already at new location." This ensures all movements follow the game rules. Each player's movement is broadcast to all players and displayed on their game boards. To highlight player movement, my player is shown in red. Other players are shown in blue. Animations have been added to make movements stand out visually. Thank you for your time and attention to Team Alpha's Skeletal Increment demo presentation.